Hello everyone, my name is Subesant and today we're gonna touch on the chapter of applications and systems development. So some of the topics that we'll be touching on in this chapter will be the software maintenance phase and the change control process, configuration management, the software capability maturity model, and object-oriented systems. So the first topic we're going to touch on is the software maintenance phase and the change control process. So the maintenance phase of the software life cycle is the last step of the cycle. This phase of the life cycle is introduced after the design stage. The maintenance phase is divided into three subphases, which are request control, change control, and release control. So the request control basically handles requests from users for improvements to the software and product, and it collects information that can be used to handle this process. In the request control, there are some steps that to follow. So step 1 is establishing the priorities of requests. Step 2, eliminating the cost of the changes requested. And step 3, determining the interface that is presented to the user. So next we have change control. So change control process is one of the key stages in the maintenance phase. Change controls addresses issues such as recruiting and analyzing the problem, developing the changes and corresponding tests, performing quality control, and some other additional criteria such as the tool types to be used in implementing the changes, the documentation of the changes, the restriction of the changes effects on other parts of the code, and recertification and accreditation if necessary. And the last control is the release control, which is related with issuing software's new update. This phase includes determining which applications are to be included in the new version, release archiving, configuration management, quality control, and distribution and acceptance testing. So moving on to the topic of configuration management. This is used to handle emerging changes in software products and to properly monitor and introduce new versions of software products. There are a few definitions we need to be aware of. The first being configuration management, which is the discipline of identifying the components of a continually evolving system for the purpose of controlling changes to those components and maintaining integrity and traceability throughout the life cycle. Configuration item is a component whose state is to be recorded and against which changes are to be progressed. Version, which is a recorded state of the configuration item. Configuration, a collection of component configuration items that comprise a configuration item in some stage of its evolution. Building, the process of assembling a version of a configuration item from versions of its component configuration items. Building list, the set of versions of the component configuration items that is used to build a version of a configuration item. And the last definition, software library, which is a controlled area that is accessible only to approved users who are restricted to the use of approved procedures. So now that we understand some of the definitions, we can now move on to configuration management procedures. So the first procedure is configuration identification, which is basically identifying and documenting the functional and physical characteristics of each configuration item. The second procedure is configuration control. Basically, this is control changes to the configuration items and issue versions of configuration items from the software library. The third procedure is configuration status accounting. So this is basically to record the processing of changes. And the last procedure is configuration audit, which is control the quality of the configuration management procedures. So the next topic we'll be touching on is the software capability maturity model. So this model is centered on the concept that the performance of a software product is a direct result of the consistency of the software production and maintenance process associated with it. So in this case, a process is defined as a set of activities, methods, practices, and transformations that people use to develop and maintain systems and associated products. So the software CMM was developed by the Software Engineering Institute, SEI, who defined 5 maturity levels that acts as a guide for continuous process development and an ordinal scale to assess the maturity of the company involved in the program processes. So the 5 levels of maturity are initiating, repeatable, defined, managed, and optimizing. So let's talk about initiating. At this level, the process is usually chaotic and ad hoc. A capability is characterized on the basis of the individuals and not of the organization. Progress is not measured in this level. Products developed are often scheduled and over budget. There's a wide variation in the scheduled cost, functionality, and quality targets. Next, we have the repeatable level. This is basically requirement management. Estimate project parameters such as cost, schedule, and functionality. Measures actual progress, develop plans and process. Software projects and standards are defined, identify and control products, problems, reports, changes, etc. Process may differ between projects. This is beneficial because the processes becomes easier to comprehend. Managers and team members spend less time in explaining how things are done and more time in executing it. Projects are better estimated, better planned, and more flexible. Quality is integrated into the projects. Cost might be high initially but goes down over time. Next, we have level 3, which is defined, which deals with stuff like clarifying customer requirements, solve design requirements, develop an implementation process, make sure that product meets requirements and intended use, analyze decisions systematically, rectify and control potential problems. And this is beneficial in terms of process improvement, which becomes the standard. Solution progresses from being coded to being engineered. Quality gets a peer throughout the project effort with the entire team involved in the process. And risks are mitigated and don't take the team by surprise. The fourth level is manage, and in this level you basically manages the project's processes and sub-processes statistically, understand process performance qualitatively, manage the organization's projects. This benefiting in optimizes process performance across the organization and fosters quantitative project management in an organization. And the last level, optimizing, which deals with detecting and removing the cause of defects early and identify and deploy new tools and process improvements to meet needs and business objectives. This benefiting in fosters organizational innovation and deployment. Here we have a little visual aid in order to help us understand how the project would formulate after it passes through each level of maturity, where, as you can see, in level 1 it's completely chaotic until the project reaches maturity level 5, where you would see it has more structure towards it. And the last topic for this presentation is object-oriented systems. So an object-oriented system has the potential characteristics of being more reliable and capable of reducing the propagation of program change errors, in addition to supporting modeling of the real world. An object-oriented system can be thought as a group of independent objects that can be requested to perform certain operations or exhibit specific behaviors. So these objects cooperate to provide the system's required functionality. So relative to the software development lifecycle phase, object orientation is applied in different phases. The first phase is object-oriented requirements analysis, which basically defines classes of objects and their interactions. The second phase is object-oriented analysis. In terms of object-oriented concepts, understanding and modeling a particular problem within a problem domain. Domain analysis, which is the third phase, it seeks to identify the classes and objects that are common to all applications within a given domain. The fourth phase is objects-oriented designs, which is objects is the basic unit of modularity, and objects are instantiated of a class. And the last phase, object-oriented programming, emphasizes the employment of objects and methods rather than types or transformations as in other programming approach. And this is the end of my presentation. I hope you all understand, and if not, you can leave questions in the comment section below.